let's get started. So thank you very much for coming. My name is Jeff Lush. I'm the founder of Palamita, and today I'm going to talk about kind of a silly word, and we'll get through that very quickly. I'll tell you what that means, but securing zombies in your code. So this is an introduction to basically discovering open source libraries that may be causing security issues, and how to work with your development team or your manager or your lawyer or whoever it may be, kind of come and figure out what are the most important things to discover, and how can you start this process. So a little bit about myself. I started Palamita back in 2003, which seems like forever ago. I keep thinking it was like 5 years ago, but it's now 13. And what we do is we help people discover their use of open source and commercial source. So what libraries are they using? Where did it come from? What versions are they? And then does that have an implication on your security? Are there known vulnerabilities in these libraries? Do they have open source licenses that may be contrary to what you're trying to do? So if you're targeting the Linux kernel, you primarily have to be compatible with the GPL2. So can you do it? Can you figure that out? If you're trying to be closed source commercial, are you keeping your licenses clear so that you're not doing a GPL violation? And while doing that, we also discover a lot of old libraries, a lot of vulnerable libraries that people are not keeping track of. And so today's topic is really to help people, and I think we have a nice selection of security, programming, students, business folks. Basically, how do we all work together so that we don't have to boil the ocean, but we can slowly, without requiring tools. Even though I'm a vendor, today is not a vendor pitch. There's absolutely nothing about using a tool to do this. There's a lot of open source tools. There's a lot of things with people and processes that you can do to start basically chipping away at these stale issues. Very often come and help companies right before they get acquired. So it's a very common reason. I get a phone call on a Friday night saying, oops, we haven't paid attention to this. We have this contract that we need to sign, maybe before we sell to a big public company or maybe before we get acquired. And we didn't even think about this, and now we're kind of over the barrel. So talk about that. Well, I may take short questions during the presentation. There'll be time for questions at the end. But if you have something that doesn't make sense, please feel free to stop me and just ask. Kind of our time together to get through this. So what I'm going to go today is, what's a zombie? What does that mean? Where do they live? What are some things you can do to kind of get a health check of your product tonight or Monday? What are things I call indicator species? What are some common areas of concern that you can start? People often say, what's my first step? Talk about that. Talk about some things, particularly around JavaScript, if you're on the front end side, some things that may be causing things to be hidden. And then some questions to ask your development team, ask your managers, and then lastly, how do we decide to bake this into our process? It's very common that people do this once, and they say, oh, we did it, and then a year and a half goes by, and they're in the same place they were before. So what are some things that we can do to try to get the developers to work together? And some questions and answers. So what is a zombie? Why do we use this term? This is a term that often comes up when we're working with development teams to say, this is a library that you're using. It's not actively crashing. It's not nobody's attention is being brought to it because it's been doing its job for 5 years, maybe 10 years, just doing the job that it's supposed to do. But it has known vulnerabilities. Meaning, if somebody wanted to attack this library, they could. And so this is where things like the script kiddies run a script that says, you're using an old version of MySQL. I was able to get in. Or you got an old version of OpenSSL. And I was able to use the known vulnerability to get in. You won't know that until somebody actively tries to take advantage of that known vulnerability. Also known as a stale component. So you'll see this when you're working with developers. We got this zombie code, we have this stale component with vulnerabilities. What do we do about it? We're using it, and they're there. More often than not, we don't know they're there. How do we find them, and how do we fix them? And it's very common to see these things. Let me tell you a little bit about this. So one of the things that are most surprising to people, and this is something I see every day, we've been doing this now for 13 years, is if you talk to your CEO, you talk to your VP of engineering, you say, what percentage of our product, whether we're open source or whether we're a library or a commercial product, how much code do you think we wrote? What percentage? And every CEO I talk to says, I'm sure we wrote like 99% of it. Look at how many developers we have. Look at how much we spend on salaries. And you talk to developers, they say, I bet you we wrote like 80% of it. That seems like a good number in Pareto analysis. What we typically find is that most products are about 50% open source. And in the last couple years, it's creeped up sometimes to 80% open source, depending on how you count it, by line count, by API count. And this is very surprising to people. They will always lose this bet. If you go on Monday and you say, what do you think our percentage is? And then you go do a quick line count and third-party directory versus everything else, you're probably going to see something like this. And then the surprising thing, this little yellow thing, maybe hard to read even from the front of the room here, is what percentage did you know about? So if you went on record before you start looking and say, what open source libraries are we using? What versions do they have? And if you did your own self-test, what we find is the average company can find out it knows 2% of the third-party libraries they're using. And that is outweighed by, basically, there's some people who know a little bit more, and most people know nothing. Like if you go to work on Monday and you say, show me our list of open source. Is there just a document I can look at? More often than not, 9 out of 10 companies, 99 out of 100 companies don't have that live. They don't have that ready to go. They might be able to produce some sort of document in a week. Maybe they'll go to run a quick free Maven tool or something like that and get a list. But it's nothing that's been built as part of the process. It hasn't been baked into the security world. It's just a document that may be dead. So 2% is what people know about. 98% is unknown. And this leads to some serious issues. If you don't know you're using OpenSSL, you're not paying attention to the patches. If you don't know that you're using Mongo, you're not paying attention to firewall rules, default passwords, and things like that. So this is one thing that happens, is that people don't know they're using it. Or it was introduced and the developer is now long gone. And this leads to these stale components here that nobody's paying attention to anymore. That's what we call a zombie component. In terms of kind of a self-assessment, what type of raw numbers should you expect? So if you're the security folks in the room here, and you're saying, well, what are we paying attention to? Oh, maybe we know we're using OpenSSL, we're using Tomcat, etc. Our experience shows the average, let's call it a typical web app, a typical SaaS project, like a real commercial app. We come in, we do analysis. We're asked by companies to say, what exactly are we using? If you go look at 2011, the typical product used about 135 open source libraries, which seems like a pretty big number. When you ask the companies what percentage they knew about, on average they can only disclose 18 items, which is only knowing about 13%. So back in 2011, we actually had a better understanding of what open source we were using than we do now. And I'll tell you a little bit of what technologies kind of affected that. But as you see time goes on, more and more open source usage, more and more just raw libraries, an inflection point in the last year or two here. But while the disclosure rate, the knowledge rate goes down. And as a security person, I look at this and I say, we're using more, we're tracking less. And that this is a recipe for problems, for security issues and things like that. So why did this change? When you guys go back home on Monday and you say, what is it about our companies and our processes that are causing us to kind of lose knowledge of these things? Well, some of it is there's more open source usage, more components being used, etc. Well, first off, companies have just loosened restrictions in the last couple of years. You may have seen some very large public companies in the last year who have kind of done about faces in their use of open source and their support of open source. Many other companies are using very similar tactics to say, you know what, we love open source now. We're going to be a completely open source company. So you see these inflection points happen. We see more complex systems in use. People are shipping Linux in a container. They're shipping virtual machines. The technologies have changed. 5 years ago, probably most of the people here would have been Java, .NET maybe. Now everybody's moving to Node. Everybody's moving to these JavaScript languages which have these tiny little packages. If you're doing C++, 5 years ago you would have used the Boost library, which is I think now 25 million lines of code for one library to track. If you now are using Node to get that same functionality, add up how many Node packages make up 25 million lines of code. That's hundreds, maybe thousands of Node packages to kind of get the same kind of standard class library. And so people are using, languages have changed, go to smaller pieces, and then package managers. So as opposed to a human saying, I'm going to explicitly download JBoss, I'm going to explicitly download OpenSSL, etc., people are now kind of pushing out a little bit of the responsibility to tools like Maven, Node Package Manager, etc., where you say, I want this top-level item. And then all these they call them transitive dependencies, all these third requirements come in as well. And very often those are overlooked by the security team, by the development team, etc. So this is causing that ramp up, especially these last 2 points here. Things like Node, things like more use of Maven and others. We also see more analysis. So there were some very serious, well-publicized security issues in the last couple of years here, which caused management to look down and say, what else is going on? We were surprised by Heartbleed. We were surprised by Shell Shock. What else? What are we going to be surprised about next? So we're seeing more analysis required. We're seeing more people saying, oops, we got caught by an OpenSSL bug. Oops, we got caught by that Tomcat bug. As well as we move to like the Internet of Things, we're seeing a lot more just raw devices running full Linux stacks out there, which provide more of an attack surface. So that's kind of what's changed in the industry in the last couple of years, while I think our practices have not changed. We're still kind of doing development the way we've been doing for the last 20 years, which is developers go, we go in our rooms, we write code, we check it in, and we hope that we get our product out on the far end there. So what are some things that you could do based on these numbers? How can you kind of do your own health check? And this is not requiring a tool, it's not requiring static analysis like Fortify or Coverity. It's like just coming back on Monday and grepping your code base. There's a couple things I like using as indicator species. That if I look at, I'll pick these because Java, JavaScript, C, C++, Linux, across kind of cross architectures, cross development practices here. I pick a couple of these where I'm almost guaranteed to find them. We know everybody's probably going to be using jQuery on their front end. We know that people are probably using OpenSSL if they're doing C, C++, maybe C# development. We know if you're doing C, C++, a zlib is going to be there. We just know it if you're doing anything kind of real. And then Java World, application servers like Tomcat. So if you come in on Monday and you look and you say, what versions are we using? We know we're using jQuery. We know we're using Prototype. I know we're using OpenSSL. And you look and you see these versions or before. You've missed an opportunity to upgrade. You're running something that is known vulnerable and in such a way that it may be visible to kind of the script toolkits and things like that. These are the ones that are very commonly checked by the script kiddies, by the automated attack toolkits. And I find these issues every day, just with a simple grep, with a discussion with the development teams, etc. And how many people here have used like the National Vulnerability Database? Okay, so most people have not. So the National Vulnerability Database is basically a clearinghouse out there where everybody reports their vulnerabilities. So if we are doing analysis of open source projects or commercial projects, if we find a hole, we find a way of breaking it, we can report to the National Vulnerability Database that we have found a way of attacking the library, getting in, basically taking advantage of a defect to basically a vulnerability. And those vulnerabilities are given names. So CVE is the kind of the naming scheme that we use. The year it was reported, and then a serial number, basically starting at 0. What is this? What is the name of this vulnerability? So if we are talking about OpenSSL, 098ZE, it has a known bug, a vulnerability called CVE 2016-0703. We can all use that as a common name to talk about that particular vulnerability. So this is a great way. If you go to that clearinghouse, if you go to the name of the libraries you're using, you just do a simple search on the National Vulnerability Database for the component name and the versions, and you will get back an answer saying, is this component vulnerable or not? If it's not listed there, probably doesn't have a vulnerability. You also do need to know how to read their web results. They're going to use a lot of language like this component with this version and before. And so you sometimes need to do a little bit of human interpretation and kind of version interpretation, saying, okay, we're using zlib 111. Do we have a problem? Because the bug may be reported with a later version but saying before. So sometimes you need to do a search on the National Vulnerability Database for just the component name, and then see what versions have problems and do your analysis. This is something you can do next week, just with the web, just with some simple disclosures that you may be already tracking. But I like using this to say, if our product has these problems, These are the ones that you'd expect the security team to be on top of. OpenSSL is always, every 6 weeks there's a problem, and people are on track of it. And if you've missed these, it's a sign that the harder stuff is probably being overlooked as well. So that's why I call these indicator species. If these are broken, if a supplier gives you a product that has zlib113 in it, you know they have not done any sort of upkeep in the last 10 years. And I see this every day. Things like this that were written 10 years ago and are still being sold have some pretty serious known vulnerabilities. Yes?
So when you're in a cluster situation like that, what do you do with the vendor?
That's a great question. I like using these when I'm working with getting a commercial library from somebody, or sometimes open source as well. And I do this quick search to say, do we have any of these? Is it going to pass my first gate of what's the version of OpenSSL? Especially in the commercial case, I like finding 1 or 2 or 3 problems, and then your vendor control system internally, or you have contracts people. You can use these to say, you know what, you guys have given us a vulnerable SDK. You've given us a library or a full system that appears to have known vulnerabilities, and that may go through the support team. Just like if you have found a bug with your supplier, it may rise to the occasion of kind of a business-to-business discussion. Because what happens sometimes is you log this as a bug, and it just disappears into that vendor's support seat. Because they might not treat it as seriously as you know. They say, oh, that's great. No, it won't fix. I see very often this is a thing that will get escalated up. Because it's not just a bug, it's a potential security issue. So your vendor may have a security response team. They may have somebody who is super interested in finding these things out. If you don't get a good response, this is the time to bring in your business folks, bring in potentially up to your lawyers. I see this is very often something that gets escalated up to the legal team to say, hey, we signed a contract that said you guys are going to do more than just the best effort to keep us secure. And look, you're shipping a 5-year-old copy of OpenSSL. And I don't. What happens sometimes in development world is, hey, we logged a bug, nothing happened, kind of disappears. And one of the things I like to say when we're talking especially primarily developers, if you find something like this in code that you're paying for, you should raise hell. This is the thing that you're paying good money and you expect to get good quality software. And if you're finding things like this, raise it up to a level. If you're not getting good response from the support team, bring it to your business person. If that person can't get it done, I think this is the perfect thing to escalate to the legal team. Because if you guys get hacked because of this, it's your name that's going to be associated with the vulnerability. They're not going to care about some small XML, commercial XML processor that you purchased 5 years ago. So that's a great question. Thank you. And it doesn't have to be perfect. One of these is enough to say, hey, we got a problem. And it'll keep your vendor on their toes, especially for your interest. So what are some things I learned from some of the recent high-profile vulnerabilities? So the security folks probably know these names really well. Heartbleed, Drown, Ghost. There's sometimes, a couple different thoughts on this. A lot of people don't like these well-named vulnerabilities because it seems like, well, this is 1 out of 1,000. Why do we give Heartbleed a name and Drown a name as opposed to just saying, hey, it's yet another vulnerability in an open source library? But in some ways, there's good marketing, there's good publicity on these things. I think it sometimes helps the security team to get some profiles about, hey, look, the industry cares about this. There's things that are coming in. There's sometimes things so high profile that the industry needs to take care of it at once. And one of the first ones in recent memory was Heartbleed, which was back in April of 2014, where OpenSSL, which is a very popular cryptography library that pretty much powers the internet. Like 80% of all sites are powered by OpenSSL. Had a very serious vulnerability, and it was given a name called Heartbleed. It was also given a CVE number as well. And then right after, others were found: Drown, Shellshock, etc., where basically security teams gave them names. And in general, if you are starting an analysis process at your company, I do recommend you do start with some of these, because if you're shipping Heartbleed, which people are still doing, I see Heartbleed every week when we come into public companies who are shipping current products. They're still shipping the version of OpenSSL affected by Heartbleed, and it's because it was checked in 4 years ago. Nobody paid attention to it. It's not actively crashing. I do recommend, whatever you think about the merits of giving them names or not, they are public, and it's a thing that your CEO may know. Hey, are we affected by Heartbleed? Are we affected by Drown? It's a great place to start because you can also get buy-in from your coworkers to say, hey, I'm coming around, I'm checking on Heartbleed. I want to find every place we're using OpenSSL. Can you help me figure that out? Drown, help me find my glibc. Help me find Bash, etc. for these very high-profile things. And people back in April 2014 did a huge, kind of almost like a Y2K style. We're all in this together. Let's try to figure out what's going on. And we eradicated a lot of the known usage of Heartbleed back then. But I would still say, I think most of the use of Heartbleed has still to be discovered. And it's hiding in places like code bases that nobody ever checked. So kind of open source libraries that didn't have a lot of buy-in from folks, but your developers might be grabbing. Compiled commercial libraries, where it's not explicitly saying OpenSSL in your file system, but buried inside the DLL or the shared object or the alt binary is a compiled version of the old version of OpenSSL. Old RPMs. Some of the talks I've been at today where people are saying, I built my product 3 years ago, I tried to do the automatic upgrades, and it broke my product, so we had to revert back to the old RPM, kind of the DLL hell, if you guys remember that from a couple of years ago. We're just, hey, I built it at a time, it works at a time, if I try to upgrade any of the versions, it's broken. So you see this, where people are trying to keep old versions of products alive, maybe the vendor's even gone. These are the types of places where you're going to find these types of high-profile vulnerabilities, even in cases where your company may have done a big push to deal with these. Another place I'm seeing these more and more is stale containers or virtual machines. Things that are outside the purview of development, particularly the development team. So often we're looking at head of tree. We're all developers. We're trying to get the next version of the product out. That's our job. There's an ops team or somebody else dealing with everything, our install base, everything that got shipped. I find all the time these virtual machines that were put together 5 years ago, they're happily running some ERP system or some system that you built, and it's never had any updates in 5 years. So these are the types of things that even for very high-profile things like Heartbleed, you're going to still find, and you can find on Monday like 20 copies of these if you're working in a company of any size. One thing I will say is, you come back, if you say, hey, this is something I want to start doing, using the name like Heartbleed is, I think, a good way internally to say, we're trying to improve our security posture here. We're trying to kind of dig through and find problems that may exist. We very often are looking at the head of tree. We also need to look back in time a little bit. Use the name Heartbleed. Pretty much everybody in the industry knows that name, the shortcut to kind of explain what you're trying to do. And by saying, we expect to still find it, I think you can get some buy-in from management. You can't boil the ocean. I showed some of those numbers before. If you go back and you say, hey, we only know about 15 libraries that we know about, and you probably have 500, there's sometimes paralysis. It's just like any sort of static analysis. I'm going to run find bugs, or I'm going to run Fortify on my product, and next thing you know, you got 10,000 findings. You're like, well, I guess I'm not going to do that. And so I find by saying, bite off bite-sized chunks. So I don't have to be perfect to get rid of ways of attacking my product. There's 5 or 6 places I think are very they're target rich. That by looking at these, and these slides will be available afterward. If you say I'm going to look at this and this and this and this, you're going to find probably 1 or 2 vulnerable components in each of these that are also the things that are going to be targeted by people running scripts, etc. outside. So number 1 is cryptographic components. So this is anything doing encryption. Hashing as well, so things like OpenSSL, other in the commercial world, RSA, that are going to be doing cryptography, basically giving you cryptography. This is probably one of the first things to look at. This is where you're going to find your OpenSSL issues. This is where you're going to find that you're using a 15-year-old copy of the commercial RSA library that people paid, lots of money for 5, 10, 15 years ago, and never went to the support site and got the upgraded version. Very target-rich, very easy to find, and I almost guarantee that most of you guys are going to find a broken version of OpenSSL if you just correct the word OpenSSL. Great place to start. This is also something that you may find in the commercial libraries that you've purchased that they didn't tell you. They should be telling you. open source licenses behind this require them to tell you that they're using OpenSSL, that they're using these other libraries, and 99% of the time they're completely silent. So if you find one of these, it's another case, like your question before, to say, hey, company, we paid you a lot of money, you're out of compliance with maybe with the vulnerability, but also you should have been telling us that you're using OpenSSL in the first place. We shouldn't have done your job for you to figure out that you're shipping us something that's open source. Compression components. So this is zlib. It's a very famous name. I like using zlib like an indicator species because if you're doing C, C++, or C# work, or even in a lot of the other packages where it ends up being wrapped by whatever your Python or whatever language you're using, you almost certainly have zlib in your product at some level. And zlib is a great component. It's small enough that they've kind of squeezed out all the vulnerabilities over the years. But there are some very popular versions that have known vulnerabilities, like zlib 113, zlib 121, and 122, that you will almost certainly find in commercial code that's been given to you, or old wrap. You got this old Python wrapped native component that somebody put together for Windows 32 15 years ago, and you've been using it because it's the only person that ever did it for you, and it's gotten old and stale. So look for those things. Zlib is another great name. There's grep for zlib. You can grep for, there's a term, inflate, space, and then the version number. So like inflate 113, inflate space 113. If you see that, you're using zlib 113. Another really simple test to figure that out. And again, if you see it both in the source and the binary form, it's a great way to kind of figure out what's going on. And if it is binary, you need to track down and say, where did we get this binary? Who gave it to us? Did we compile it? Is this commercial? And then do that same path that we talked about before. Use that maybe as a key to say, I think this whole binary is tainted. Zlib is 10 years old. What else is 10 years old? Multimedia components. So FFmpeg is our indicator species here. If you're doing any sort of video or audio, great way to find potential issues there. Very often wrapped and hidden because you're getting it from commercial suppliers or your developer said, oh, God, we got to play video. I'm not a video programmer. Let me go grab FFmpeg. It's a very big project. It has a lot of plugins. It may have some licensing issues. It may also be other things like that because of the type of programming that we have to do. Make things fast. We need to show video very quickly. We're going to kind of have to do shortcuts to blip those bits that often lead to kind of the buffer overflows and things like that lead to vulnerabilities. And then the last three things here often end up being overlooked by us in the development world. We're looking at libraries and source code. There's things here that end up maybe being more on the DevOps side or the IT side that cause our products to have vulnerabilities. So like application platforms. So are you using Tomcat? Are you using JBoss? The Java world kind of got surprised by Heartbleed because we said, oh, we're using Java. We're not affected by OpenSSL. We don't use C code. But Tomcat had a native version of OpenSSL compiled into like the DLL native optimized coroutines that make the SSL processing faster. So you may have been affected by Heartbleed even though you're a pure Java shop.
Do you happen to know what version that got fixed in?
I do not know, but it would have been whatever it was. It would have been they did something, May of 2014. So probably any version after May of 2014 was probably fixed. And it may not affect you depending on your code path, but it was a surprise to our company. We went and said, well, we got to make sure that we are very pure, and let's go look for the word OpenSSL. And this Tomcat 32 DLL thing came out. We're like, what the heck is this? And then we figured out that was OpenSSL being used with Tomcat. So look at your application platforms. You're using the Windows world. You might be living on an old version of your .NET framework. It's very common that people are on PHP, and it's a very ancient version of PHP. They can't upgrade, but they're now vulnerable. This is sometimes something that you can use with your management to say, we can't live on this old version of PHP anymore because we can't even patch it. Databases are another big source of old libraries that you don't control. The DBAs do it. So talk to your DBAs if you even have a DBA. It's very often that these orphan Oracle databases or MySQL databases that the old architects set up because they were the only person that knew how to kind of care and feed it, and they've moved on and they're like the Roman aqueduct. They outlive, they keep working, but nobody knows how to fix it or where they are. And then lastly, operating systems on the Linux stack. This is something where it's like, hey, we built our product. God knows what happens to it. Look, it gets wrapped on some virtual machine that's downloaded. And the dev team didn't decide which version of Linux on and got pickled 2 years ago, and you still have a problem. So these are the things that you can, from probably the easiest to the hardest, that I like to start with, because they have known named components. You don't have to boil the ocean, and you kind of explain why you're looking at each of those. Okay. Another thing I like to do is do an interview with my dev team and draw something like this on the board, which is, I call it the layer cake slide, or just kind of the layers, the stacks that you're using. So many times when we talk about security, we just talk about the source code that goes into our app. But if you're doing anything like software as a service, or you're putting together containers, you're putting together virtual machines, you actually have 7 or 8 layers that people often ignore, or that different security teams are looking at. So you might be using something like Find Bugs, or PMD, or Fortify, or Verity to do static analysis up here in your classic product. But maybe you have utilities that you shell out into, or you exec into. Or there's libraries like the system-level OpenSSL, or the system-level MySQL that maybe use Puppet to get out onto your system. So if you just scanned your source code, you would never see MySQL. You would never see the system-level OpenSSL. And if you just talk to your dev team, you'd say, did you guys ever check in OpenSSL? Nope, never. But if you look at your Puppet config, you'll see that it's putting it into some Linux system in production, and it's specifying some ancient version. The various drivers, if you're in the Linux world, so I don't know, people doing embedded devices, it's very common to see these old versions of the kernel modules there. Pickled versions of the kernel. Your QA team said, we only work on Linux kernel version 3.14.4. Don't ever change that. We haven't validated it. So that becomes embedded in your requirements, and your customers dutifully go out and install like a 4-year-old version of Linux that's been patched many times since then, but your docs team never updated this. So it's another place where I see people get in trouble is they validate on one version, and they probably should say or later, or periodically every 6 months change those version numbers, but they get set in stone. The PDF got made nicely 2 years ago, and they never get updated. And then less likely for most of the folks here, but if you are doing any sort of IoT or embedded device, things about your firmware and your bootloader, this is often what people are using to attack, to like boot your device and things like that. That's outside of the scope of today, but something to pay attention to that often gets overlooked. And one last thing, the web services. So it's becoming more and more important for people to say, let's track our user data. And they say, does our data ever leave our offices? No. Well, but by the way, we save it on Amazon Web Services, or we're doing social media, or we're doing antivirus scans of attachments using an external web service. And next thing you know, your EULA says your data never leaves our company, and a developer says, oh, but we got a virus scan, and let me use Virus Total or something like that. And next thing you know, every document submitted is going someplace outside, and you just broke your own EULA. So another good question when you would talk to your team is, what web services are we using? And use some pointed questions. Are we doing credit card processing with authorized.net? Are we doing virus total scans and things like that? Because it's very common to say, I'll say this a couple times today, but are we using web services? And everybody in the meeting goes, no web services. And you say, are we using the Google Maps API? Oh yeah, well, that's a web service. So everybody has one of these circle diagrams. I think in general, the main thing to take away from this is if you just do it once, we talk about all these like things that you can do. If you just do it once, you're good. I don't know, for 6 weeks after that, 2 months after that. But if you don't build this into your process, you're going to end up fighting the same fires over and over again. So when the next ARC lead comes out and your CEO says you're going to work this weekend to figure it out, because you don't have a nice piece of paper that says here's every version of OpenSSL and where we're using it, you're going to find yourself fighting the same fires over and over again. And I also find sometimes that we say we're not going to dedicate people to this. So there's a developer who's not working on something right now. Okay, go do this. And then they get busy and they start doing some real stuff. And when you come back to them and you say, okay, it's your time to do it again, they say, I'm too busy to do it. And so you now have to retrain somebody with all this vocabulary and all these tools and all this again. And then they got to relearn all the mistakes and so on and so on. So I'm a big believer of dedicating somebody on the dev team, usually 2 people, to be kind of an heir and a spare, to say, figure out a process. What tools are we going to use? Are we going to be grepping? Are we using find bugs? There's a great free tool from OWASP that does a lot of these lookups for you. Can you do the care and feeding of that? Can you look at the Maven output? Can you look at whatever, the Node Package Manager output? Just kind of check this against the National Vulnerability Database. Can we just make sure that we're looking at those top 5 things, our crypto libraries, or multimedia, et cetera? And make sure you do it. Build it into your process. Because if you don't bake it in, it's a one-time thing. It helps you out, but it doesn't keep you guys safe. So a couple things is like, what's a great way? I like doing what I call the conference room effect. So just like today, we're all here. If you pull people into the conference room and if you ask them one by one, are we using any open source? Everybody goes, no. And they say, what's our database? Oh, it's MySQL. Oh, MySQL is an open source database. We're using open source. So if you get people in the room, whether it's real or virtual, on Slack or whatever, and start asking questions. I have a set of pointed questions on the next slide, but that's the best way to do it. If you ask people one by one, you don't get that good network effect of people's answers helping other people and prompting. Get them together. If you do this a couple times, you're probably going to uncover anywhere from 20 to 200 libraries just from asking people what they're using, what they know about. And so you save yourself the time of having to corrupt the code base and things like that. I'll talk about the pointed questions in the next list. But if your contract people aren't giving you the list of known commercial dependencies, hey, we're using this SDK from Broadcom, we're using this from Microsoft, etc., you should get that, because these are things that probably have their own upgrade paths. If you're using like the Microsoft Office embedded DLL, there's probably a free update for that. But your team probably got it 3 years ago. They checked it in. It's not actively crashing. Nobody's checked. Figure out what you paid for. And especially if you paid for it, it's a great way of passing the buck. Like, if you've paid good money for a library, go talk to the support team. Say, have you guys done any security updates? Use that list of things before to prompt it, and then have them do the work. Have them do the heavy lifting. Classic code reviews, great way to figure this out. If you add to your code review saying, is this open source? Yeah, this is a library, it's open source. Is it on our list? No, well, let's get it on the list. And keep doing it. And then if you can do some open source scans, keep doing that as well. So this is kind of the classic Fortify coverity scanning, and this is the explicit, let's go look for open source and commercial code. And if you have those as explicit points on your release criteria, it gets done. So here's some good questions I find, and again, this will be available afterwards. I find that even in a 1-hour phone call, we can double our list of known open source and find things like very serious vulnerabilities just by asking a series of questions earlier. We have a list of open source and commercial code. First place to start. Somebody says, no, and somebody says, oh yeah, we did this. We did an OEM relationship with this big customer about 6 months ago. We have a list of about 100 things that we found. Great. The lawyer might have it. The technical manager may have it, but it's not checked into, it's not on the wiki or anything like that. Great. Save yourself some time. If you don't have one, I look at that as kind of like, well, we should have one. Why don't we have one? We're breaking our open source, the licenses that expect us to do these disclosures. We're out of compliance. We need to do that. How deep have we looked? That's always a question of like, have we gone down to like the molecule level, or are we just looking at the top level libraries? Because sometimes people say, oh yeah, we did a really deep bug scrub. We found everything. And the list is only 7 items, and you realize that one of those items says Ubuntu Linux. Well, we probably have some vulnerabilities in Ubuntu Linux, and we don't have a version date on it. That list of 6 items I talked about before, ask this, again, 2 pointed questions. Are we using any cryptographic components? No. Are we using OpenSSL or RSA? Oh, yeah, we're using those. So ask both questions, because you want to know that you're using OpenSSL. You want to know you're using RSA. You also want to know that you're using this oddball crypto component that came from Code Project or, Eastern European website with one person's name on it that's not even a complete name. Those are the good questions to ask. People always overlook things brought in by repository managers. So it's very common that I get a list of disclosures from somebody that said it's all based on the .java source code or the .javascript source code, but they totally overlook the Maven files. They totally overlook the Node Package Managers, which maybe you might get 50% of your dependencies from these package managers. And it's very common to see that. It's also very common to sometimes only get the repository manager things. So you got a combined C project and Java project, and you get a list of 100 jars from Maven, but they totally overlooked OpenSSL. They totally overlooked zlib. It's just because somebody ran a free tool, gave the list, even without even looking at it, said, oh, here's my disclosure. So ask pointed questions. Ask how they produce that list. You'll get some insights into it. The web services we talked about before, again, with some very specific names. Google Maps, Authorize.net, Iris Google. The databases, and somebody say, oh, we don't use any databases. It's like, wait, we have millions of records here. We must be using a database. Oh, well, I'm sure we're using something. And ask for the various versions. We have a SQL database. It's probably going to be Oracle, MySQL, Postgres, MariaDB. I was at a really good talk earlier today where the person found that their component changed. They thought they were using MySQL, and behind the scenes, the component manager changed it to MariaDB, and their demo failed. And that was just because their repository managers made an automatic upgrade for them and kind of changed it from Oracle MySQL to MariaDB. So what SQL database are we using? Are we using NoSQL? And again, use an explicit name. Are we using MongoDB? Are we using et cetera, et cetera? Again, often typically handled by an IT team that you might not know that would be there. Embedded. So are we using SQLite? Are we using Derby? Use these names. Again, ask them both ways and post it. Oh yeah, we're using Amazon Web Services. We're using whatever, RDS, et cetera. You may be using all of these for different purposes, and sometimes people just stop at the first one. What's our database? Oh, it's Oracle. Great. Well, we forgot about Mongo. We forgot about Oracle. We forgot about et cetera. After you do this, eventually you may want to get into virtual machines and containers. How's our product get delivered? Are we shipping it? And what is our long-term strategy for supporting this? It's very common that stuff outlives us all, running 5 years, 10 years later. And what's going on there? A good technique here is if you come across one of these and you don't see a copyright date newer than like 5 years ago, I basically consider that container tainted. There's been no automatic upgrades. Nobody's been doing the care and feeding with it. That's also a very simple way. If you look at your own product from a couple years ago, what's the latest copyright date? If it says 2010, I'm going to assume the whole thing's vulnerable. Full stack, that was that layer cake model, and then disclosure list from commercial folks. Okay, so how many people here are front-end folks, JavaScript? A couple. So the place I see that kind of gets overlooked in the JavaScript world is when people do minification. This is when you take the original JavaScript and you kind of make it optimized for deployment. You kind of remove all the variable names and comments and things like this. This sometimes will change it so that your security teams are not aware that a certain version, like jQuery, is being used anymore. So now basically it looks like line noise, and the version name may be gone, the version string may be gone. So one of the things I like saying is have a best practice. Always keep the original unminified version in your code base. If you're going to use the minified version in production, great, but treat that almost as your exe. Like take it from the original form, minify it, and then deploy. What happens a lot of times is somebody minifies it on their desktop, checks that in, and it's a new version or an old version, and you silently get version creep or version unstaleness. Yes?
Are you raising concern of the minimization just from a detection standpoint, or
there's nothing that's going to make it. Probably theoretically, the minification may cause a class of vulnerabilities, but this is more about, hey, I didn't even know I was using jQuery because very often people concatenate these things together as well. So it might just say, JavaScript.js, and you look inside it, it's got a minified version of jQuery and prototype and this and this and this, that if people are looking for it, can overlook it. That's basic change of best practices there. Yes. Yes, I'm sorry.
Hi. So there's a very important point that I think was missed.
Mm-hmm.
You've referred to OpenSSL a lot of times,
yes.
And that's also true to zlib and a lot of others, by the way.
Yeah.
Most products do not statically compile OpenSSL
Mm-hmm.
onto their binaries.
Yes.
Nor do they compile shared libraries of OpenSSL.
Mm-hmm.
So looking into the source code is irrelevant in multiple cases.
Yes.
And what you really should be looking at is what distributions of links you run, not looking at your headers. Because the same header can be, in production, wherever that may be, and it may not even be yours, it may be your customers.
I totally agree with you.
That's a very important point and very missed point, I feel, in your presentation.
Sure. I agree with you. So that was part of that when you asked about what version of Linux are you using in your distribution. That is to get to that point. Sorry if it wasn't clear. What versions are you explicitly using, and what versions are you inheriting from your system libraries?
And the follow-up thing that I do have to say is you mentioned package managers as being introducing problems, whereas I see it actually the other way. The package manager gives you a perfect option and ability to tell exactly what you've got installed, and also to inspect what possible upgrades you can have.
Totally.
And looking at change logs.
Yeah.
And the best way to do that is A, make sure that you're using a distribution that keeps updating, what they call LTS, long-term support distribution version, and subscribing to the security lists for that particular district.
Yes, and I would totally agree with you that use the tools that come with your repository managers and actually check it. I find 90% of folks use the repository managers and don't ever check. There's a free tool. Show me what I got. Show me what I can upgrade to. That's usually not built into most people's processes, at least the ones I've seen.
And one last point, when you do auditing, you really want to do it with DevOps, because your development teams may not even be aware of the exact version is running in production.
Totally agree. That's good points. Thank you. Let's see. So make sure we're running out of time here. At some point, you probably want to get into subcomponent analysis. I think it's probably okay to leave that for now, but your first level is like, let's figure out our big rocks. You're going to get a lot of low-hanging fruit there, but eventually you're going to want to do some subcomponent analysis. They may be on the commercial code you're inheriting, and maybe on the large pieces of code you're getting. If you're keeping on track of Tomcat and you upgrade Tomcat, that ecosystem's going to take care of you as time goes on. If you're running something like Red Hat and you do the right update, that ecosystem's going to take care of you. But if you find yourself using a large library that has many multiple pieces, maybe do a quick grep for the word copyright, and you see so many people's names go by, that's probably a sign that you're using a very large library that has a lot of moving pieces. And as developers, open source folks, we do our work, we love our library for a while, then our attention wanes and we move on to the next library. Sometimes you're going to find something that looks good, not actively crashing, but it has a lot of subcomponents that nobody is upgrading. Or it has OpenSSL inside of it, just to pick on a well-known thing, and it never got upgraded. Maybe because they didn't know it was there, maybe that it was fine, it's actually not causing a security issue and they've checked it out, or maybe just because the team has moved on and they're no longer doing it. So at some point, do some subcomponent analysis, again, using the same techniques that we did before. And then, at some point you may say, you know what, we see there's a version of OpenSSL in this library here. Let's go ask a question to the team. Let's go on GitHub and say, hey, we see that you're using a 2-year-old version of OpenSSL. Do you think this is a bug? Have you seen this? And they might say, thank you very much. That's the most common answer I see. Or they might say, oh, we've done a security review. Don't worry, it's fine. I don't know if I always like to hear that answer because, especially if we're not being paid, if we're not doing a lot of static analysis, it may be kind of a best guess as opposed to a real targeted attack. How many people here use like Fortify or Coverity in their daytime job? So one person, a couple people. So at some point somebody might say, oh, run static analysis tools. So Fortify, find bugs, Coverity. These things find bugs. These find like security issues in your code. And what happens a lot of times is people think they're running it across their entire code base, including the open source. And a lot of times the licensing models for these tools, or just the use model, kind of like when we talked about before, you ran it and you get 10,000 results. People go, oh, I can't do that. Let me just go look at this or look at this. At some point, you may find yourself, or maybe somebody at your company running Fortify or Coverity. The important thing to know is where are they running it? A lot of times management thinks that every single line of code was analyzed by these tools. And very often you'll talk to the person running the tools and say, I ignored all the open source stuff. I just looked at our stuff because we got 30 million lines of open source. I'm trusting that they're doing it. So find that out. Figure out where you're using the static analysis. Are you dividing your code base into scanned and not scanned? Are you doing it much more targeted? And do you have a best practice, like all results have to be dealt with, or just ones in your heart of your system or of certain types? And also know that vulnerabilities are not always caught by static analysis. There's a huge class of known vulnerabilities in commercial code and open source code. There are things like, they put an embedded password in that says password, and you deploy your thing, and people just can come in from the outside with password. We see this in routers all the time. We see field/service as a default password. So you can't always find that. And that's a good reason to use things like the National Vulnerability Database and whatnot to catch things that you won't find yourself. Another thing is never scan something that you already have an upgrade path for. If you're using zlib 113, don't waste your time. There's a nice free upgrade path for that that's well vetted. Kind of a quick test here as you guys start to look at it. You can't scan your way. You can't scan everything. So if something's on the NVD, if you're using OpenSSL, there's maybe 1% of companies in the world that are probably going to get value out of doing crazy deep static analysis of OpenSSL. You might be the company that finds new vulnerabilities. But for most companies who are just doing standard development, just watch your versions. Upgrade as required. Fix firewall issues as required, etc. So if it's on the NVD, that's a sign that people care, and people are probably running this through the full spectrum of tools. Yes?
What is NVD?
That's the National Vulnerability Database. So if you type in NVD into Google, I think it's nvd.miter.org. It's a database of known security issues for open source. If it's up there, sometimes people read that as, if it's up there, it's bad. Like, I look at it as, if it's up there, it's good. It's important enough that people care about it. They're spending time out of their own time to find problems, and then they're reporting it. So if it's up there, I almost take that as a badge that people are using it. If I find crypto code that's not, you don't know the name of it, and it's not on the NVD, I'm like, is anybody else using this? Am I the only person about to be the first person to push this out to the deployment? So if it's on there, I would say, probably don't want a static analysis. Just look for the versions that get upgraded. If it's ancient or abandoned or just not well known, if you're getting it's brand new, it's 6 weeks old on GitHub, or it's 16 years old out on Code Project, you might want to throw some static analysis at it, especially if you're in C and C++. Yes.
One other thing is that, as a general rule, the company that has the vulnerability discovered against it assigns the CVE. If they don't, it often doesn't get a CVE.
Yes.
So if it's not ever on NVD, that could mean no one's looking at it. It could mean they're just not willing to fix anything.
I agree. So that's why I look at it as almost a badge of a good cycle of finding and fixing. Not always, but better to see. I think it's better to see it there than nobody's that good. Nobody's never created vulnerability. So, old version scan. It's very common for big companies that they have to fork the old version, and even though there's new versions available, they're kind of stuck on this old version. A lot of backporting may be required there. You may find yourself suddenly, it's like somebody gave you a puppy. You own this now for the next 10 years. And if something's small, if you got a snippet from a book or a blog or a gist or Stack Overflow, you may be the only. These might have been made as proof of concepts. Here's how you do it, but it really wasn't designed for production. And this may be something that it kind of was anointed as it must be good. It's on the blog. You brought it in, and there aren't the quality checks. There aren't the things like that. This is sometimes where I see kind of the most interesting stuff come in. So the last slide here, and we'll have any time for questions if there's anything left, is getting developer buy-in. This is the hardest thing I've seen. Being a security person and saying, "Come on, we don't want to get bit by these things," and everybody says, my management told me I have to write code. We have to get the product out. I have feature. I don't have time for maintenance. I don't have time for this. So sometimes getting the developers on your side, or being a developer and saying, "Hey, I want to try to. I don't want to have to work the weekend because we didn't spend 5 minutes now. I'm getting called in to fix the next heartbleed." Try to get some more disclosures of your open source. So if you're the person bringing it in, you should know. If I went out to the internet and I brought something in, I'm checking into Git. Let me get it on my list. It's a 30-second side effect of me going to GitHub and bringing it in. Let's get it on the list. Even if there's no vulnerabilities, nobody ever gets something that has no vulnerabilities. It comes out 6 weeks later, 6 years later. Let's get it on the list. Figure out who that owner is. And if you don't have the owner for a list, make somebody or become the owner of the list. It's always good to give credit where credit's due. I find that works very well with co-developers. They're saying, if we're using somebody else's stuff, let's give them credit. So even if somebody says, I don't want to do it, it's like, well, you want to give credit, don't you? That's something I have found work. Sometimes the "we're required to" works. Some people want to do it out of goodness of the heart. Sometimes you can blame it on the lawyers or blame it on the security team. Like, I worked all freaking week because we didn't know what OpenSSL was. My husband or wife is angry at me. Like, use that war story. Let's prevent ourselves. And sometimes I've seen people make it development gates. We've seen it where if you make the VP of engineering sign off that they know all the open source and commercial code, they have to put their physical signature down. They make it so that you get enough time to do it. If they're not forced to write their signature down, they're like, oh, I'm sure my folks are doing it right. And then open source ethos. Hey, we want to give money to the open source teams that we're working with. If we don't know who they are, how can we support them? Put a kitty of money. Is it $5,000, $10,000, whatever's appropriate? Whatever our most popular open source library is, we want to give $1,000 to everybody, to that thing. We want to, we'll give you time to fix the bugs, and then how can we provide support? So these are some things I found I've worked with dev teams and security teams to kind of make your job easier. Like as a security person, you can't get things on the disclosure list, but you can kind of get some buy-in. So with that, I think I'm at the end here. So you guys have asked some good questions along the way. Any other questions? Yes.
So as a developer, how do you pressure product management to say hey, we're using this old library, and we need to upgrade it, but that's going to cost test effort, dev effort.
Yeah, that is one of the hard things. I mean, I think sometimes it helps saying, hey, I went to a conference and somebody thought this was important enough to give a presentation on. That sometimes is okay, because nobody wants to be the first person doing it. The war stories, like the Heartbleed issue, you can point to the literature saying, look how many person hours were spent doing this after the fact, and look at how people got hacked, etc. We're starting to see, if, depending on your industry, like automotive, health, etc., it's becoming one of those things where there's actual liability. Hey, we didn't do the right thing. It was clear that we weren't doing the right thing. That caused some issues for it. But any comments?
That's another answer to that is if you either have the skills or know someone who has the skills or can find an example, a proof of concept solves a lot of problems when you can show someone that the thing they thought wasn't a big deal should be terrifying.
I totally agree. I think so many times you hear people say, oh, it's not a problem. And you come in and you say, look, I just broke in. And look, it was 7 lines of Python code. Very compelling. I guess that's some point. Yes?
Yeah, I mean, just to answer your question, I've been in applications so often. I've been working in a security company, but I'm actually just a developer. But I'm the only one who's really thinking about it.
Yes.
So I'm from the developer perspective, and I'm trying to motivate. We have to do these things, and it's important. And they're just people above, essentially, who are writing the checks. Basically, they just don't. They want product, right? They want features, and you have to essentially quantify it. You have to somehow quantify it in values that they understand in terms of man hours, in terms of loss of basically cash from customers. You have to just basically map it to that, and then essentially make sure they understand risk and get them to sign off on it, and then it's therefore now their problem. If they're not willing to deal with it, give you time to deal with it, then it is their problem.
I totally agree. I think this is a case where developers, security people, and legal and compliance sometimes can work together. Like, hey, legal people, we haven't been doing open source compliance around licensing. That is sometimes one of the biggest benefits to security, because you can use the legal world to force compliance, which gets you, as in the security world, a very nice bill of materials with versions. You then can start doing your NPD checks and things like that. Yeah, there was a question over here.
Another thing I found that works really well with product management is you come back and you say, hey, we have a certain kind of industry standard for how quickly we need to respond to security issues. And this library might have a new version that didn't update any security issues. But if we're not constantly upgrading versions and testing the incremental changes as they go along, when we do have a security issue and we rev up to that version, we find us introduced bugs elsewhere, we're spending extra time on that. And we're going to make it slip and we're going to fail the version.
Totally agree. So many Java shops get in trouble where it's like, oh, we haven't upgraded Tomcat in 3 years. And then when you try to do it, it is such a nightmare because everything breaks. That is one of the biggest reasons where people stay on ancient versions, and I think that's an excellent point. Iterative little pieces from time to time, and also just say, you know what, we can't be more than 6 months old on Tomcat. Just even without a vulnerability, we should make it a best practice. Excellent way to stay on track. So I think we're at the time here. I want to thank everybody very much for coming by. I'll be available after.